We're going to take a look at some ratio tables today. They are really helpful for organizing your thoughts. All of us make mistakes when we're solving math problems involving fractions and decimals in our head. And it's really important to organize your numbers, and the ratio table is a perfect way to use that. So far we've looked at ratio tables with multiplication and division. So for example, we might have seen a problem like 22 times 27. And we might have taken one group of 27, and then we would have looked at two groups, and that would be 54. And then we might have looked at 20 groups, and that would be 10 times bigger, so 540. And then we would have taken these two together and got 22 groups, which is 594. So 22 times 27 is 594. That's one way we've used a ratio table. We've also solved division problems with ratio tables. So 126 divided by 3, we might have looked at one group of 3, and then we might have looked at 3 groups being 9. That's not nearly big enough. Maybe we looked at 33 groups being 99. That's still not big enough. But we do know that 9 times 3 is 27, so we could do 9 more groups. So we could do 42 groups is 126. So we know that 126 divided by 3 is 42. That's two ways we've used ratio tables. Let's use them a different way today, though. So when Mr. Pierce went to the store, he needed to buy gumdrops for our science a couple weeks ago, and he needed 10 pounds of gumdrops for us. And he found them on sale, 2 pounds for $1. And that might have been something you can solve in your head, but he used a ratio table to organize his thinking. So if he knew that the money and the pounds, remember I said it was 2 pounds for $1 and he needed 10 pounds. So if you did 10 right here, we know from 2 to 5 is multiplied by 5, and so he was looking to spend $5, and that seemed like a reasonable amount. But I also want you to think of that as a fraction. So if we look as a fraction, we see that for every $1, he gets 2 pounds. Good. And then for every $5, he gets 10 pounds. And so now we see a ratio table as equivalent fractions. 1/2 is equal to 5/10. So this ratio table this way, when we turn it horizontally, we're looking at equivalent fractions. Let's take a look at a problem that I had to do. I had to buy granola for my household, and I needed 11 pounds of granola for this really big recipe for granola bars. And I looked on Fred Meyer online, and they had 5 pounds for $6. And then Safeway had them on sale for 2 pounds for $3, and I really wanted to know where I wanted to buy that granola. So let's solve the Fred Meyer one first. So we have 5 pounds for $6. I know that I have 5 pounds is equal to $6. But how do I get to 11 from there? I know I can get to 10 pounds for $12. That's getting closer. And so again, we have equivalent fractions. 5/6 is equal to 10/12. But now I want to go back to the unit fraction. I want to know what 1 pound is. And if I want to go 1 pound, I divide by 10 and I get $1.20 a pound. Well, that's interesting. Now I can put the 10 and 11 together, and I know that 11 pounds is equal to $13.20. Okay, so there's one price, but we need to look at what Safeway costs, don't we? So Safeway is 2 pounds for $3. So if it's 2 pounds for $3, I could find the unit fraction right away. I could find out that 1 pound is $1.50. So right away I can say Safeway costs more, but let's look at that $1.50 compared to Fred Meyer was $1.20 a pound. So let's go up to the 11 pounds just to make sure. So I know that 1 pound is $1.50, so I could do 10 pounds is $15, right? 10 times bigger, move the decimal 1 time over, and I could put these together and I have 11 pounds is $16.50. So I'd really want to go to Fred Meyer, wouldn't I? No, that's not an advertisement for Fred Meyer, but that's where I went to buy my granola for my granola bars. Okay, so let's do another story problem. Mr. Cork needed to buy toothpicks for an upcoming science experiment, and he checked the price on Walmart, and he could get 50 toothpicks for for 25 cents. Wow, that's an incredible deal. But then he went on Amazon and he looked that the price on Amazon was $3,000 for $18. And if that was a better deal, maybe he was going to buy the $3,000 because that is something that we might use again in the future. So let's use a ratio table to compare the price of those. So here we have Walmart. Let's figure out if 750 toothpicks at Walmart is a better deal, even though it would be a ton of boxes. So we have 50 toothpicks for 25 cents. That seems like a good deal. So I want to see what $1 would be. So $1 would multiply by 4 quarters and $1, and 50 times 4 is 200. So we know 200 toothpicks is $1. That seems pretty good. And let's get up to 600. So 600 toothpicks, that's 3 times as much. That'd be $3. And if I add 3 groups of 50 to that, we could get up to 750 toothpicks, and 3 groups of 25 cents would be $3.75. Okay, so he says that's a pretty good deal. So 3,000, that seems like a really good deal, but let's divide and see if that really is a good deal. So let's split 3,000 in half, and that would get us to 1,500. And split $18 in half, that would be $9. Okay, looking good. And if we split 1,500 in half, we get 750. And if we split $9 in half, we would get 450. So when he looks at these prices using ratio tables, he actually realizes Walmart has the better buy. He has to buy a lot of boxes, right? But it would be cheaper than buying the huge box on Amazon. So I hope you use ratio tables in the future to show your thinking and better understand that we can't keep the math in 5th grade in our head. When we work with fractions and decimals, we need to use ratio tables and models and strategies we've learned to increase the accuracy of the problems we're solving. Thanks for working with me to get today, 5th graders. Bye.